Okay, so now we're doing the 5.1 to 5.2 review. Your test is Tuesday. And there's some of the type questions that are like vocabulary questions that are real fast. I did scramble the questions to make it like it'd be the test. Like you don't just have all the 5.1s together and then all the 5.2s. So it's kind of jumbled together. This one's from 5.1, number 5. This is from 5.2, number 6, and so forth. Then this one's from 53 on 5.1 and so forth. So it's kind of like a random order this time. So the first one says f of g of x is f times g, and that'd be false. Okay, the next one, if every horizontal line intersects at no more than 1 point, it's called 1-to-1. So those are your definitions. So remember, like y equal x cubed is 1-to-1. Y equal x squared is not, but is a function. So in other words, your y can't repeat for it to be 1-to-1. Your y cannot repeat for it to be 1-to-1. Okay, number 3. This one, you're trying to choose your variables, your function names. So you start with the outside one, which has to be f, and it's something to the 7th. So we have this, and that's it. Okay, so x to the 7th, and then your g would be the inside. So the g is the inside, and the f is the outside, which is something to the 7th. So that's a, right? Okay, number 4. The domain of the composite function is the same as the domain of g. That's only sometimes true, so it's going to be false. So, like we've done before, if you do f circle g, you need that domain, and you need the g domain, and you put them together. Sometimes one of them is all real numbers. Sometimes both of them are fractions. And then also remember, if you're doing g circle f, you need the f domain also. So if you're doing the g circle f with the f, you should not put the g domain. And if you're doing f circle g, you should not put the f domain. So just a couple of quick reminders about that. Okay, number 5. The graph is given. Use the horizontal line test to see if it's 1-to-1, and it is. Yeah. And find the inverse. So you have Lisa on the left and the points on the right. So now you have the points on the right and the names on the left. And 155 goes with Lisa. So it's this one. So Franco had 121, so that's why it's not that one. And then the domain of the inverse would be the numbers, which is B. And the range would be the names, which is C.
What is that noise?
This table.
Why are you making it?
Okay. All right. So
That last one I couldn't.
It's
C. Okay. So now for this one, this is the start of like some of them that are a little harder for you guys. We have f circle g of 4. So we could do g of 4 first. And so that's going to be 3 times 4, which is 12. And then we do f of that answer. So we have 7 square root of 12. Now, the part that's challenging to some of y'all is about simplifying your square roots. Remember that we need to break it down into like perfect squares. Yeah, so 4 times 3. Because if you did 12 as 6 times 2, then you have to go again and say 3 times 2, and there you have your pair of 2's. So it's a whole lot easier if you divide by 4, 9, 16, 25, etc. to make it simple. So what that means is the square root of 12 is the same thing as 2 square root of 3. The square root of 12 is the same thing as 2 square root of 3. So if you have like two numbers that are the same, you put it on the outside. You could even think of that as square root of 4 times square root of 3, if that helps you, which is 2. And then your leftover part goes under. Now, you got to now substitute this for this part. So we're going to do 7 times 2 and then square root of 3. So that's 14 square root of 3. 14 square root of 3. So that's how you do part A. Any questions? Okay, for part B, we're doing f of 2. So if we plug the 2 in, we get 7 square root of 2. And then you do g of that, so we say g of x equal 3 times 7 square root of 2, and so you get 21 square root of 2. And then this one, we have f of 1. Now, remember that the square root of 1 is 1, and so on this one you get 7. Then you have to do f of 7, so you get 7 square root of 7. Any questions about those? Okay. Then g of 0, so we get 3 times 0 is 0, and again, g of 0 again is still 0. So you get 0 for your answer. Okay. Next you have your table, and this first one you're doing f circle g of 1. So this is the one where you just need to take steps. Do g of 1 first because it's on the right side. So you go to 1, you go to g, and you get 0. And then we do f of 0. So you go to 0, go to f, and you get negative 1. So I know this is something that some people struggled with at first until you started doing some on your own, but I think most of y'all have the hang of that. We're going to do g of negative 1. What do you get for g of negative 1?
0.
Right.
F of 0 is negative 1.
F of 0 is negative 1. Right. Right. And then this one we're doing f of negative 1.
0. Nope. Negative 2.
Yeah, negative 2. And then g of negative 2. So we go to negative 2, we go to g, and we get 3. Any questions about that? Okay, so now f of 0 is negative 1.
And then g of negative 1 is 0.
G of negative 1 is 0. Right. And then g of negative 2.
It's 3.
So go to negative 2, go to g, which is 3. And then we want g of 3. 3g, 7. And f of negative 1, negative 1, f is negative 2. And f of negative 2, negative 4. Okay, I'm just going to pause there for a moment. Remember, there's a Math Excel review also, and if you make 80 or better, you get your extra 3.
And then this is 3 too?
This is 3 also. Okay, number 9. If the domain is 5 comma infinity, the range of the inverse would be the exact same thing, 5 comma infinity. So it's just the same. Because this one's the domain of f, and this one's the range of f negative 1. So basically, if you have your function f of x, you have a domain and range, and for your inverse f negative 1, you have a domain and range, but these two are going to match, and these two are going to match. So your domain of this one's going to match the range of this one, which is what we have. Any questions?
No, sir.
Okay. Okay. Determine whether it's 1-to-1. Looks like if you work 10 or 15 hours, you get $100. So that'd be no. So basically, everything has to have its own number associated with it. So if you have 4 numbers and 3 numbers, then it's not going to work out to be 1-to-1. Okay, number 11. This one, you want your inverse function, and so it already, let me say that again. It already has your curly braces, and so what you're going to want to do is put your list of ordered pairs, but you just reverse them because you switch x and y. So if you have negative 11, negative 3, then you're going to have negative 3, negative 11. And you have 1, 7, so you have 7, comma 1. And so forth. Don't try changing signs. That would be like probably the error if somebody makes a mistake on that one. This one, 3, negative 10. This one, negative 8, negative 3. And this one, 0, comma 7. Okay, next we have the domain of the inverse. So you look at what you just put for your inverse function and choose the x's. So we have negative 3, 7, 3, negative 8, and 0. So don't bother ordering them least to greatest. That might confuse you if you did that. Hopefully not, but then on this part you do your range, so it's just the y values. So again, domain is x, range is y. So you have negative 11, 1, negative 10, negative 3, and 7. Okay, number 11 was done. Number 12. If x1 and x2 are 2 different inputs, then 1-to-1
Is A is not equal to.
yeah, they can't be the same. Right. Cannot have the same y value. So that's why it's a not equal. So basically, x cannot repeat and y cannot repeat, and so that's why you need the not equal. Okay, number 13. F of x equal 9x is 1 to 1. Find the inverse and graph. Okay, so for this you switch x and y, or switch x and f of x. I'm going to start by saying y equal 9x. I'm changing f of x to be y. And now I'm going to switch x and y and then solve. Okay, so we have x equal 9y, and then you divide by 9, so that cancels and you're done. X over 9.
Or 1/9 x. That's what I thought.
Yeah, or 1/9 x. Right.
It's like that on Math Excel.
Right. It accepts either way. So you could think of it this way. The inverse of a linear function is still a linear function. Both of these are linear. If x were on bottom, it'd be rational. Okay? So the inverse of a linear function is linear. Okay, now on this one we want to graph it, and you have your y equal x's. So let's see. It's a steep graph that goes through the origin. This doesn't go through the origin. Yeah, it's B. I just wanted to make sure we ruled out choices. So basically, think of 9x is pretty steep, and 1/9 is not.
And then x, y equals x.
Yeah, and then the y equal x would be through the middle. Any questions about that? Okay, 14. If f negative 1 denotes the inverse of a function, then the graphs are symmetric to y equal x. So again, that's one of your definitions. So y equal x was for all of those. So it's here too. Okay, number 15. Complete the sentence. Given two functions, f and g, the blank function denoted f circle g. Yeah, that's composite.
Would be f of g of x.
Yes, f of g of x. So this one looks like inverse. This one's just adding. Okay, number 16. So this one is quadratic. So we know the domain of a quadratic is all real numbers. And this one's just shifted up also. And so that one would have looked like this. And it's all real numbers. So those are our original domain. So now we want f circle g. So you start writing your f function, so it's going to be something squared, and then you plug this part into it, so you've got x squared plus 2.
Plus 2.
Just x squared plus 2.
Oh, yeah. Okay.
Yeah. Okay. So now, at this step, you have to simplify it. So think of it as x squared plus 2 times x squared plus 2, if you want to, and then do FOIL. So you get x to the 4th plus 2x squared, and 2x squared makes 4x squared plus 4. And so that's what would go in the blank. I'm just going to draw the arrow. And the domain of a function to the 4th power is also all reals. And so for f circle G, we think about the f circle G domain, which is all reals, and the G domain, which is all reals. So there's no limitations, so it's B. So this was quadratic with quadratic. Any questions on part A? Okay, part B, they want G circle F. So you start writing your G function. Since it's on the outside. And so your G function is something squared plus 2. And then you plug your f into there, which is x squared. So x squared squared is x to the 4th. Yeah, then plus 2. And again, this is all reals. And the original was also all reals. So G circle F is all reals, F is all reals, so that makes it all reals. Any questions? Okay, on C, you're doing F circle F. So start writing your F function, and so that's something squared. And then you plug in the F function to that, and so you get x squared squared, which is x to the 4th. And again, that's going to be all reals for both. Then on G circle G, start writing your G function. So that's something squared plus 2. Then put x squared plus 2 here. Now we did the x squared plus 2 squared as this answer, because that was the x plus 2 squared, so we can take this answer, x to the 4th plus 4x squared plus 4, and then add 2 to it. So x to the 4th plus 4x squared plus 6. And that's that answer. And again, it's all real numbers. Let's do 2 more today, and from there you can work on your Math Excel. So I don't want to finish the review completely today since the test is Tuesday. Okay. So this one, consider the function and its rational function. This might be the hardest question on the test. On the review. So basically, for this one, you start writing your f function. So that's 5 times something plus 8 over something plus 3. Then you're going to put your g of x into it. So you put 3x minus 8 over 5 minus x. And do that in both spots. So at this point, what you want to do is distribute the 5. Now it only goes to the top. It doesn't go to the 5 minus x. Okay, so 5 times 3x is 15x. 5 times negative 8 is negative 40. Okay, so my first step was only distribute the 5. Okay. The next step, we need a common denominator for the top. So that's going to be 5 minus x. And we already have the 15x minus 40. So we need 8 times 5 minus x. And we need to do the exact same thing to the bottom. Put a 5 minus x down here. And we already have the 3x minus 8. And so we put plus 3 times 5 minus x. Now, if you're doing it right, these should cancel, the 5 minus x and this 5 minus x, because they're in corresponding positions, like the second and fourth position. In other words, if you multiplied your outsides, which are your extremes, and your insides, which are your means, then they would cancel. Okay, from there, combine your like terms. So we've got 15x minus 40, and then distribute. So 8 times 5 is 40, so that cancels, and then minus 8x. So that's your top. And then the bottom should be 3x minus 8 plus 3 times 5 is 15, and 3 times negative x is negative 3x. And so your 3x and negative 3x cancel. So what we have is 15x minus 8x over negative 8 plus 15. Well, that reduces to 7x over 7, and so after everything, you just get x. So that time, you just get x. So when you're doing f of g of x, we need our f circle g domain, which would be all reals because it was just x, as well as your g domain. So let's go back up to the top. This f domain would be x not negative 3 because you just change your sign of your denominator. So think x plus 3 equals 0, so it's negative 3. And this one would be x naught 5. So you look at this part, x naught 5, and between real numbers and naught 5, you have to do the naught 5. Any questions? Okay. Now we're doing g of f of x. And so we start writing our g function, which is 3 times something minus 8 over 5 minus something. Make sure you put parentheses in this denominator one because you're going to have to distribute a negative sign at some step. Okay, and let's plug in the f function to it. 5x plus 8 over x plus 3. 5x plus 8 over x plus 3. Okay, so just like on the other one, we want to distribute the 3 to the top only. So this would be 15x plus 24 over x plus 3 minus 8. And on this one, I want to distribute the negative 1 to the top. So I get plus, and then I'm going to want a negative 5x
minus 8 over x plus 3.
Any questions? Okay, now you want a denominator of x plus 3. So we have our 15x plus 24 minus 8 times x plus 3. So again, since we wanted negative 8 and we wanted a common denominator, we had to put the x plus 3 there. And on this one, we also want x plus 3. So we need 5 times x plus 3. And then ignore the plus sign, because plus a negative is just negative. So we get negative 5x minus 8.
What is that?
Okay, so here we're going to cancel out the x plus 3's and then distribute. So you get 15x plus 24 minus 8x minus 24. Because negative 8 times 3 is negative 24. And here distribute your 5, so you get 5x plus 15 minus 5x minus 8. So your 5x minus 5x cancels. And your 24 minus 24 cancels. So here it looks like 15 minus 8 is 7, so we get 7x. And 15 minus 8 is 7, so those cancel. And once again, we just get x. So again, after all that work, we just get x. So now we're doing the G circle F, and so the G circle F domain would be all reals because it was just x, and then the F domain would be x naught 3, negative 3. X naught negative 3. And since both of them were x's, they would be inverses. If you got different answers, like one of them 3x and the other x, then it'd be no. Any questions? Okay. Okay, then this one says f of 7 equal 5. So remember our general thing is f of x equal y. And our ordered pair would look like 7, 5. Because your x would be the 7, your y would be the 5. And so on this one, you already have the 5, and so then your answer is 7. Okay, that's going to be our stopping point for today. We'll finish the rest of this on Monday. Now you can work on your Math Excel.